The key to creating powerful chatbots or any other applications powered by LLMs like OpenAI's ChatGPT lies in providing them with proprietary or private information. So when they reply to you, they can make use of that information to provide personalized, tailored, eminently helpful results. In this video, we're going to building just exactly such a chatbot that makes use of the personal information. But before we go into the technical details, let's do a sneak peek into how the final solution would look like. First thing to note is that here we're asking a question about year 2023 and the default ChatGPT has a knowledge cutoff in 2021. Still, we get a reply. That is because we provided it with a proprietary knowledge base. Here it shows you some reasoning on top of the proprietary data, which has the population and the percentage of women in that population. And here we show that even though it can reason on top of the knowledge base, it can also reason outside of the knowledge base, so basically doing this normal LLM functionality. With that being said, let's look at the exact technical implementation of this chatbot. We start with importing Chat OpenAI module from the Langchain chat models, as well as this human message schema. We'll go over into more details of what different messages there are, but roughly there is human, there is AI message, and then there is a system message, so the one that sets the background for the AI agent. Here also make sure that the OpenAI API key is defined in your environment variables. We instantiate the object of the Chat OpenAI class. And for now, we set the debug to false. It is set to false by default, but we'll play with this debugging along the way. Cool, so we run those two. Now we start talking to our chat OpenAI. Here we say that there is just one message from a human, and that message is this: what is the population of the German capital of Berlin? And then those are the messages we'll pass to the model, and then automatically gives us the response. Let's give it a go. So it says that as of 2021, there was roughly 3.8 million people registered in Berlin. And now we want to continue the conversation. So we ask, hey, how does it compare to the population of London? And we pass it on to the same ChatGPT object. And as we do that, it tells us the population of London in 2021, but it loses the context that we were referring to Berlin in the very beginning. And here it kind of tries to find its way out and says, well, therefore, the population of London today is much larger than it was during the time period in question. So it didn't compare it to Berlin. And actually, depending on the run, this this reply can be different. So if we run it one more time. Okay, now it says to provide a comparison, the population of London is approximately 9 million people, but it doesn't really provide the comparison. Once again, let's give it a go. I'm curious. Yeah, and now it says, okay, to provide an accurate comparison, we need to know the specific population you're referring to. So it completely loses the context of the previous question. That's why we call it forgetful chatbot. Now let's improve it by adding some memory, so it will remember what we spoke about before. Let's do a very short detour into what Langchain is before we do the memory part. So what Langchain essentially is and why it is a chain, it takes your question or the user input or the piece of data, and then it passes on through the chain of steps. And those steps can be different. So here in the official website from Langchain, ignore the retrieval part on top and also ignore the memory for now for a second. So it takes the question and then it generates a prompt out of this question, so step 1, then passes on to LLM, step 2, it retrieves an answer from LLM, step 3, and those are the steps, and that's what Langchain is about, and it can get this chains can get very complex. So in our case, without the memory, we're getting question, prompt generation, we'll look at that later. Basically, the question was passed on to LLM, and we're retrieving the answer, so no idea of memory. Now we're introducing the memory. So the question, it will be passed to the LM, the answer will be retrieved, and then we'll store that in the memory. So next time we ask the question, there is this idea of the memory. Here we use the conversation buffer memory. It's one of the simplest memory types. It simply buffers all the previous messages without doing any sort of pre-processing. For example, there is memory type that would do a summary of all the messages, so that kind of saves us space. But in this case, we'll use the most simple one, and here we say, okay, so the input from the user was this. I just copy it over from here above. And this was the reply from AI. If we run that and we print the content, you'll see that there is one human message, so using the same schema that we imported here. And then there was one AI message. Cool. Now we'll start making use of the chains, as it was described just a second ago. We'll use Langchain. It's a very simple chain, the most basic one. And then we'll use the memory, and then we'll use a prompting as well. So now you will see the difference between the user input and the prompt. Let's run that. Again, don't forget to set your OpenAI key environment variable. Now template. Template is something that is populated and then passed on to the LLM. So in our example, every time LLM talks to, every time Langchain talks to LLM, it will pass on these, like this exact text. It will be previous conversation, then it will pack all the chat history next to it as text, and then there'll be text again, new human question, and then it will pack our question into here, and then we'll kind of ask LM to give us a response. So this is the template we're using. And prompt, it basically, it's just wrapper against, around our template. And we'll say this is our memory, the one we looked at in the previous cell. And then we construct a chain. We construct a chain out of our LM agent, in this case ChatGPT, and then the prompt that we defined here. Here's the prompt. Then we set verbose to false. We'll set it to true later. And then memory. We say, hey, start not from scratch, but from this pre-populated memory. So now at this point, our agent knows that we spoke to it, that we spoke about Berlin and the population of Berlin. And that's why we expect it to kind of be smarter this time around, replying to our question about comparing it to the population of London. Now, if we run that through, as of 2021, the population of London is 8.9, making it significantly larger than Berlin. So it remembered the context of the conversation. Here we also see the chat history printed out. We just gave it a custom key name here, and that's our previous conversation. And that's what made use of when generating this reply. Cool. And now let's ask it a couple more things so you get a feeling of how it works, and then we'll move on to adding proprietary knowledge base. Now we'll push further, and then we'll ask, hey, how many languages are spoken in London? Again, you see the chat history got inflated by the previous question. So here it remembered the previous question here and the previous reply. And it says, well, according to some census, there's over 300 languages spoken in London. Great. And now we want to be like really specific. We want to be really specific and go back to the Berlin question, but ask for the population in 2023. As we do that, we get the standard reply that it doesn't have access to real-time data, and its last knowledge update was in 2021. And this is where we could help it was providing some custom knowledge base. So let's look into the custom knowledge base step. Lots of stuff happening here. We don't need this one. But our custom knowledge base will be simply stored in this text file. Let's take a look at the text file. So this is our custom knowledge base, which I completely made up, but it's not too far from truth. So I'll say, hey, as of 2023, Berlin population is roughly 5.5 mil, and 51% are women. That's our custom knowledge base. Here we make use of this handy class text loader. There are different loaders. You can load PDF, you can load pages, you can do all sorts of things. So here we're just making use of the most simple example. If you have questions how to load your type of data, just leave a comment. I'll cover that. Here we're making use of the vector store. Now, why vector store? In this chain now, we're now start making use of this storage or the knowledge base. Under the hood, this information, so this text, it's not stored as text. It's stored as numerical vectors. And the reason for that is then when we ask the question, the model, actually it will be the LM, it will need to compare how relevant the information in our knowledge base is to answering our question. And to do that, the LMs, they vectorize the data, and then the comparison is run very simply on the vector. So our text is represented as literally lists of numbers, both our knowledge base, but then is also same thing with our question. And then those vectors are compared. And if the similarity score is reached, then the data in the proprietary knowledge base marked as fit to be used for providing the answer. Okay, so here we'll load it. Chrome is just kind of local vector store. Again, we instantiate our ChatGPT, we instantiate the memory, sorry. And then we say, okay, now we'll make use of a different chain. So there it was just simple LLM chain. And here's called conversation retrieval chain. What it incorporates exactly this extra step of retrieving information and knowledge. And also does some funny things to this template here. So under the hood, it has very specific template, and actually we'll work with that template in a minute. Cool, so we have our LM here, our retriever here. So from the text here, this argument here, I set it to 1 because by default it's set to 4, but our data set is so small that its default setting kind of causes the error. So we'll say, hey, we just have one row of data and then the memory. So we run that. And now we can ask our chat with memory and with knowledge questions that have to do with our proprietary information. So what's the population of Berlin as of 2023? And it says that of 2023 is exactly the number that we specified in the file. And also keeps track of the history. And now we can go further and we can ask, because we also have some information about the kind of the ratio of women in that population. We can ask, hey, how many of them are women? And okay, so it did some math here. It says, okay, so in total there was 5.5 mil, and therefore the approximate number of women is around 2,777,727. So it did the math. Nice. And it made use of this knowledge base. And now let's do something very interesting. Now let's get back to the context of London. Let's say we decided to change the topic of our conversation and we say, okay, let's talk about London once again. Hey, how many languages are spoken in London? And what we see is that it says, I don't know the exact number of languages spoken in London. Now let's explore why that is so. For this, I will enable this Langchain debug parameter here. And let's see what Langchain does under the hood with the prompts. So in the end of the day, it cannot tell us the population of London, even though it kind of was able to do that just a minute ago. So we turn the debug on and run the same question.
A lot of information here, but here is some useful steps. So first, this is what it passes on to LLM, our question and the history. And then it does very interesting thing. It asks the UI, sorry, the LLM, to rephrase the current question so it becomes a standalone. So to rephrase our follow-up question, take into account the chat history so that our now question becomes a standalone question. So the LLM can answer the question without referring to the history. This is how it works under the hood. Really interesting. And LLM kind of crunches that and says, okay, so actually the question without the context, so the standalone question would be this: what is the number of languages spoken in London? Which is not too far away from our really initial question. And now let's see what happens next. Now our Langchain or the chain looks like this. This is our question, the one that was reformed by LM, and this is our proprietary data. And now under the hood, Langchain does this. This is the final prompt. Remember the prompt that the Langchain sends to ChatGPT. It says, use the following pieces of context to answer the user's questions. If you don't know the answer, just say that you don't know. Don't try to make up the answer. And then passes on our private information as context, and then passes on the reformatted question. And because of this instruction, use the following piece of context to answer the user's question, the question about London, it just doesn't work because using the context, it cannot answer the question about London. It has nothing to do with London, our information. That's why in the next step, we'll go under the hood, we'll change this prompt so that if it cannot find an answer to our question in the private data, it will ignore the private data and try answering the question as if it wasn't there. So I'll set it to false once again to keep things clean. Here I just copied over the code from the above block with the only difference is that here I set a new template which is called test template, terrible name. And here I copied over the template text from the above with an exception that if you don't know the answer the question once again, ignoring the context. So this is basically the key part here. Right? And then here's the placeholder for our context, and here's the placeholder for the question. And then our prompt gets generated from our template, and we say, yeah, there are two placeholders, one for question, one for context. This, you see, we do it here manually, but then Langchain did it for us under the hood automatically in the previous example. Same thing, we instantiate the chat with memory and knowledge. And now once again, let's test it with Berlin first. So let's see if it still picks up our private data. Yes, it picks up the private data. And now let's ask something that out of the context of our private data. So how many languages are spoken in London? And as a result, yes, it's an AI language model. I don't have access to real-time data. However, London's a multicultural city. You see, well, it didn't give us that exact number of 8.9 million, but it already provided us some context. So it didn't say, I don't know. We could actually run it again because the results of these LMs, they are not deterministic. And, oh, that's the languages? Okay, let's try it one more time. See, and now it says, okay, I'm AI model. However, as of my last available information, estimated that over 300 languages spoken in London. So now it does both. It can access our private information and it can access just common knowledge, which is cool. Now, finally, we're wrapping it all up in a Streamlit app. I won't be focusing on the Streamlit app internals. I'm focusing on our chatbot here. So all of that you could look up in Streamlit tutorials. It's all very basic. Here, what's important for our use case is we instantiate the OpenAI instance, load our proprietary data, put it into the vector store, Here's our customized template that says to use the knowledge or use the context and to ignore the context if it didn't help to answer the question. Here's our prompt from the template. Here we define our memory. Here we instantiate our conversation retrieval chain. Yep, more boilerplate from Streamlit. Let's launch the app. It's Streamlit run and then the file with our app, which is chat. Slick looking interface, I like it. What is the population of London? Okay, as of 2021, I think was somehow relying on context too much. Nice, so we can answer that as of 2021. How about Berlin in 2021? Well, here it's kind of cheating. So it took our number from 2023 from proprietary knowledge base. Let's push it further. Let's say 2020. Ha. Well, so you get the basic idea. It works. You can also ask for some general knowledge, something like how many countries are there in the world? Okay, so it answers the general knowledge questions. It makes use of the proprietary database. But the thing is with LLMs, they are never deterministic, so you always need to go under the hood and make sure it works for your specific use case. And also, rarely are two answers are the same. So as I was preparing for this recording, I was getting slightly different answers than the ones that we get here. I hope that was helpful. I tried to convey the basic idea, give you a good feeling of what LMs are and how you could interact with them. Also building a chatbot with Langchain. Do let me know if you have any questions or feedback, and I'll make sure to incorporate that in my next videos. Take care.